Hello y bienvenidos. I just checked my calendar and it's that time of the year again. Jiggle physics. Love them or hate them, the fact is that they can make a great impact in your game. You already know what jiggle physics is, no need to deny that. So the least I can do for you is teach you the right way to implement this in Unreal Engine. In this video, we will use a free character you can download and add to any project. Then, tweak the physics asset to add the physical bodies. Use the animation blueprint to start the simulation, and as a bonus, I will show you how to create a chest slider as the respectable game developers that we are. To start, let's create a blank project and give it a proper name. I said proper. Now, import the character to our project. It can be any character. I'm using Shimby from Paragon so everyone can follow along. With our character imported, let's create a basic map and drag and drop it to test that everything works correctly. Select the character and change the auto-possess value to player 0. If the cloth of the character is freaking out, it's not because it knows what we're about to do. It's because of a collision setting from the cloth asset. To fix it, double-click the skeletal mesh asset, then click on Activate Cloth Paint and select the one that says Arm Cloth. Here, open the Chaos Cloth config section and remove the checkmark in Use Self Collisions. Now let's try playing again. And you will see that the cloth is working correctly, but we cannot move the character around. This is because the character is using the legacy version of inputs, so we need to do a little bit of tweaking. Open the project settings and go to the input section. In this section, add the missing axis mappings that are used for the movement of the character and for the camera, and also the missing action mapping used for the jump. You can get rid of the extra input events if you want to stop seeing the warnings. Also, I'll tweak the lookup scale to -1 to make the camera easier to control for me. If for whatever reason your Paragon character starts misbehaving, don't let your intrusive thoughts win, and just restart the editor. This will bring the materials back to normal. Something that I failed to mention at the start due to our excitement is that the main requirement for this feature to work is that the skeleton must have breastbones. Without these bones, we can't proceed ahead, so make sure that your character has them. Now, let's open the physics assets of our character. Here we need to show all the bones in the hierarchy, select the breastbone and add a sphere body. We can tweak the size and location manually using the widgets, but I prefer to change the values in the details panel. Now let's show the constraints and select the one we need. First, we need to lock the angular limits. Second, we need to change the linear limits X and C motion to limited and the limit value to 5. As the last step here, we want the position target linear motor to affect the X and the C axis, and the strength to be 500. But I must warn you, I crashed several times in this step, so make sure to save before simulating the bodies. The times I didn't crash was when I put the values to 1 first, then simulate, and after I tested it with the real values, return the other values to 0. Also, you can copy the Spine 3 body, delete it and test your simulation so it doesn't block your mouse when you're trying to drag and drop with your right click while holding the Ctrl or Shift key. After the test, you can paste the body back to the skeleton if needed. When you finish with one side, you can go to the skeleton tree and mirror the body. Don't forget to click on each body and change the physics type to Simulated. With that out of the way, we need to enable the physics on those two new bodies. Let's open the animation blueprint, and in the animation graph, add a rigid body node. Connect it after the leg IK node. And while selected, change the physics asset to the one we tweaked. And change the component linear acceleration and velocity scale values to 0.5. Save and compile everything and test if it's working correctly. If you receive a result similar to mine, it means that the mirror action we did before in the physics asset is trying to censor us. So the way you get around it is with good old hard work. Open the physics asset again, delete the right breast body and create it from scratch. Save everything and try playing the game again. Now everything is working correctly, and I must reveal that this is the setup that I use for any type of physical body simulation, not only just breasts. It works great for hair, chains, and cloth. You must have realized that you were tricked. Yes! Tricked into learning useful stuff when you just wanted to see some jiggle action. So, let me make it up to you. Let me show you a quick way to have a slider control the size of any character's body part. But did you know we have an action game course with a lot of bonus content and lessons? You know what? This is not the time for that. Check the description for more info, but we have something more important to do right now. The concept to control the size is pretty simple. Just increase the scale of the bone, and that will move around the vertices affected by that bone. For this operation, I will use Control Rig. So let's create one for our character by right-clicking on the skeletal mesh and selecting Control Rig. Open it, and from the rig hierarchy, drag and drop the breastbones. You can get and set the values of the bones this way. I want to set the scale, so I will create a float variable called breast scale with a default value of 1. Connect that variable to the setTransformBone node and do the same for both the left and right breast. If you get weird deformations, it's not the shame catching up to you. It's because Control Rig doesn't seem to like when you copy and paste nodes, so we need to drag and drop the right breastbone from the rig hierarchy again and set it as we had before. The last thing we need to do here is pass the previous values of the bone location and rotation. Now let's go to the animation blueprint and make use of the Control Rig. Right-click and type Control Rig and connect it. Select the node and inside it set the Control Rig class to our Control Rig asset. Make sure that the breast scale variable is set up as instance editable, so we can use it in the AnimGraph node. Don't forget to compile. In the animation blueprint, promote the input to a variable by right-clicking it and give it a default value of 1. This next part is kind of optional, but it is a good idea to remap the values used in this type of situation. I just want an alpha value that will go from 0 to 1. When it's 0, the scale will be 1, and when the alpha is 1, then I want the scale to be a maximum value, which I decided to put as 2.5. I'm creating variables for these values, so later on it's easier to tweak if I change my mind. Let's update the animation blueprint by clicking on the Control Rig node and enabling the Use Pin box. I'll rename the breast scale variable to breast alpha and make sure that everything works, and that the variable default value now is 0. Our animation blueprint is working, so we can start creating the user interface. Let's create a widget blueprint and name it slider. Inside it, we will have a canvas panel, and on top of it, there will be a slider. Change the anchors by holding Shift and Ctrl and click the middle one. In the character blueprint, let's create a debug input for quick testing. Here, we will create the widget and add it to the viewport. I see that it's a little small, so in the widget blueprint, select the slider and change the size and the render transform scale. With this, we need to handle how the inputs will be treated. In the character blueprint, we will specify when do we want our UI to receive the input, and when do we want our game to do it. Also, we need to tell the game when to remove this slider. I'll separate the widget creation logic so we are not spawning multiple widgets. When I tested this, I couldn't return to the game, so I will change the input mode from UI only to UI and game. The last thing we need to do is connect the slider to the breast alpha value in the animation blueprint. Select the slider and go to the onValueChange event. Create a variable that will hold the character. The character holds inside the mesh, and inside the mesh is the animation blueprints, which is the one that has the value that we are looking to change. So through the anim instance, we are able to get and set the information we need. We can test the game, but it isn't working. Don't lose hope. We're in too deep to back out now. We just need to fill the character variable that we created. So go to where we created the slider widget, and inside the character blueprint, set the value we need. We're done! But if you're picky like me, you will notice that the second time that you open the slider, the value resets to the start. To fix this, go to the widget blueprint, override this function, and get the value from the animation blueprint. Now we're done for real. Time for you to apply what you have learned today, and feel free to leave this video playing in the background, so the engagement is high and YouTube finally starts recommending our content to everyone. Have fun! And I will see you in the next video.